everything but pi. Basically, it's
So
like, is this the same as this? Go ahead.
okay, so I have the formula where it's arc length equals 0 over 360 times 2 pi r. And
Yes.
then with that, I'd start filling it out. So I know the arc length is given to me, which is 6.4 pi.
Yes.
Is it always pi?
No, they're just being kind to you
Okay.
by putting pi in the
Um,
answer.
all right. So yeah, I guess in this case, 6.4 pi. And then we know 144 is what's needed for is it the central angle?
We need the central angle. That's what that theta is in this
Uh,
it refers to the central angle.
so what would we call the 144? Because I understand how we get it, because there's that circle with a 216 with
It's the
T.
it's the central angle.
So that's the central angle. Okay, so then
Yes, of the arc. It's the
of the
same
arc.
measure as the arc. Yeah.
Okay. And then so then we get the 144 over 360 times 2 pi, and we know the radius is 8 because that's given to us as well. So then so then our final thing would be 6.4 pi equals 144 over 36 times 2 pi times 8. And then we get rid of the pi's in this
You're
scenario.
you're you're not solving, you're just verifying. So you just need to make sure that the right side equals the left.
So would we then multiply the or not would we solve
You
144 over 360 times
you
2.8?
yeah, divide and then times 2 times 8.
Um, so would it be 14?
All of this 144 divided by 360 times 2 times 8 should give you 6.4.
So I guess you could look at it as, oh wait, yeah, that was
You're just
bad.
going to the
Yeah,
you're going to
my
the calculator. There's no
yeah. I already got it open. All right, 144 divided by 360 times 16 is, yep, 6.4.
Okay. All right, very good. Ready to do the next part of this?
And so I'm okay, wait, so the 6.4 is just verifying
Yeah.
the um the arc length. Or like what did all that just verify pretty much?
We're just making sure that the numbers they gave us like work. So
Uh-huh.
I think about it this way. If they didn't give you the 6.4 pi and they told you that the radius was 8, you would on the right hand side calculate the arc length to be 6.4 pi. You're just validating that what they have is right.
Hmm.
It's like when someone hands you the check and says, "Can you add this up and make it's right, make sure it's right?" You're just confirming what we already know to be true.
Okay, so it's just basically just just like checkup work pretty much.
Yes.
Okay. And then I'm done with that problem once I do that.
Everything's done. Yes.
Okay, all right. I don't know why I don't really remember doing this.
Well, you got kind of another shot here. New problem here. It says use the circle in part A above to find the area. So I'm going to snip in that circle next so we can have it to look at.
So using the circle in part A, find the area of the shaded sector.
Yep, you start with, and it's in here. The area of a circle is pi r squared. The area of a sector is the angle out of 360 pi r squared.
So I'm currently finding once again the like small circle within the big one,
It's a pizza slice.
the pizza slice.
Yes,
So
you're finding this right here.
okay, so do we know what the angle of T is currently?
It is the same as the previous problem. That's 212. The other angle you have to calculate, same as before.
That would be 8, 4, 148.
Or no, I gave you the wrong number. 216.
Oh, okay, my
So
bad.
it's 100. So it's
Then,
144. Yeah.
yeah, all
Okay.
right. So then 144, 8. So we know 144 over 360 pi r radius is 8 squared. And
So again,
then
you do it without the pi. That way you can get an exact answer.
do we so what's the A in this scenario? Is that just area in the
Area of the
first
sector. Sector.
area of the sector? So
Pizza
are
slice.
we so that's the pizza slice. So we're just make so we know that it's supposedly going to be like 144 or something or like how do we know? Okay, so like let me try and think of how to word it. So we have the circle, we have the pizza slice. We're solving for the area that's within the pizza slice. We believe it's 144 currently, right?
144 degrees. Think of it as a
144
percentage.
degrees.
It's 144 out of the whole.
Uh, and then and then we're using this equation right there, 144 over 360, 8 squared, to give us the exact area within this pizza slice.
The area of the pizza slice, yeah.
So then once we here, I'll just and then it's times 8 squared, correct?
Yes.
Okay, I'm just gonna type that in real quick. And then maybe that'll answer a question. So I got 25.6.
Okay, so 25.6 pi.
So then that's showing the pizza slice.
So here, I'd like you to do this. I'd like you to find the full area of the circle, which is pi 8 squared.
Pi 8 squared. That would
Yes.
be uh am I multiplying it like 64 times pi?
Just 64 pi, okay?
Oh yeah.
So this pizza slice is 25.6 pi out of 64 pi.
Mm-hmm.
It's 25.6 pi out of 64 pi. Could you
25.65.
could you calculate that for us, please?
Mm-hmm. And I can just make the pies cancel each other out, correct?
Yes, yes, exactly.
25. I got 0.4.
Like this.
Mm-hmm.
Okay. Now can you do 144 divided by 360?
144 divided by 360. I got 0.4.
Same thing, right?
Yeah. So it can have like different numbers, but as long as it's getting the same answer, it's fine.
I'm trying to show you is that 144 is the angle out of 360,
Uh-huh.
and then the area of the pizza slice, which is 25.6 pi out of 64 pi, it's the same. The ratios are
Mm-hmm.
the same.
Okay. So 25.6 pi is so that's like the total amount of space filling up that pizza slice.
So we should have units. I think it was inches squared.
Mm-hmm. Or that's the surface area, I mean. That's like if it's
No,
laid out flat,
yes,
that's
yes. We'll go with that.
that, that's like how many inches it would be squared.
Mhm.
And then obviously the entire thing would have to be actually okay, wait, no. So that's the slice. Boom. I'm not solving for the rest of the circle.
No, I mean there are problems where you do find the other area, but not this one.
Okay. Um, maybe we could come back to this like after another problem or two,
Sure,
because I think like I don't know why there's just something about this that's not clicking.
sure. Okay, here's a new problem. I think this is the next one I see on there. It says given sine theta equals 8 over 17. Sketch a diagram and find cosine. So you want to draw a right triangle, your favorite right triangle. Maybe this is your favorite right triangle.
Uh-huh.
This is theta. And then you have to remember the three relationships. And your teacher was kind enough to give them to you here. This would be good to put on a reference sheet potentially. Although I think you kind of overcomplicated it, but it's sine is the opposite over the hypotenuse.
Mm-hmm.
Opposite over hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent.
Opposite over adjacent.
So sine theta is the opposite over the hypotenuse. So 8 is the opposite. 8 is opposite there. And then 17 is the hypotenuse.
Mm-hmm.
Do you remember how to find the other side, the third leg or the other leg of a right triangle?
Do you just make it square root of 3 of the leg?
That is
The
a
adjacent.
special triangle. This is a squared plus b squared equals c squared.
Right. Okay, yeah, that should have been the easier one to answer. So that would be
Oh,
a squared plus a squared plus 8 squared equals 17 squared. And
okay.
then 17 times 17. 389 and
200.
64. Yeah, so yeah, a squared plus 64 equals 300, 289.
Yes.
Oh, yeah. 1 times 1 is 1, not 2. Um, so then I would then subtract that, and that would give me 223. 223. And
Try
then,
again. Try again. That worked out nicely.
oh, 25. I did that last time as well. I don't know why.
It's okay.
Um,
Practicing for the final. What is A?
and then A would be, I think, 15.
Okay, so can you then tell me cosine of theta? Now that you have that.
Uh, so cosine would be adjacent over hypotenuse, and
Okay.
then that would be 8 over, no, 15 over 17.
Okay. Very good.
And then sine would be 8 over 17.
Good.
And then it would then
Tangent theta is
tan would be 8 over 15.
8 over 15. Good. Okay. Okay, I really want to clarify what we are doing in the previous problem. So maybe enough time has passed that it's clear.
Yeah, I think that like cleared my brain to see it different again.
Okay. There are two things that they could ask you with regards to a pizza slice. One is the length of the crust,
Hmm.
and the second is the area of the pizza slice.
And the area is like the total surface of it, correct?
Yes, the hash. It's right here. Yeah. Okay, so there's two formulas, and they're really similar. And I think if you see them together, you'll appreciate it here. So the length of the crust is angle over 360, 2 pi r, and the area is the angle over 360 pi r squared. Notice that this 2 pi r is really the circumference,
Hmm.
and the pi r squared is really the area.
And the circumference is the little circle in the middle of the total circle, correct?
Circumference is going all the way around the circle.
Right. Okay. So that would be, so total circumference, is that like supposed to be representing the full 360 degrees?
Yes, yes, exactly. Yes.
And then the um, area is just that slice.
Well, area is if the whole is the whole area of the circle.
Correct. Okay, so all right, so I know this might seem like a dumb question, but so would the circumference always be 360?
Well, okay, like normally before this, you learn that the circumference of a circle is 2 pi r and the area is pi r squared. So in both of these problems, when the angle is 360, they become these equations over here on the left
Uh-huh.
because the 360 divided by 360 is 1, it becomes just 2 pi r. When the angle of 360 over 361, it just becomes pi r squared.
Pi r squared. Okay. So then 2 pi r squared. All right, so yeah, I guess let's just continue on with that part. And I'll
Okay, so
just say that it all
well,
plays out.
I'll give you an example problem here, or one to try here. So let's say, again, I'm going to give you the pizza slice here, and this is 30 degrees, and the radius is 9 centimeters. We
Mm-hmm.
want to first find the length from A to B.
First line length from A to B. That is going to be 30 degrees, I
Out of
believe.
360 times.
Pi r squared.
Okay, we want the length, like a linear walking distance. You're walking along the edge.
Um,
That's the circumference when you're walking along the edge. Perimeter.
perimeter. And then that's 2 pi 9.
Okay.
Um, oh, right. Yeah. 9. Nine's on the side. That's how long it is. All right. So then, so then all I have, so is this when I get rid of the pi?
Well, the pi is going to be there. Just it comes along for the ride. It's that friend
Oh,
you don't want to bring with you, but you have to. Um,
all right. So I guess, yeah, that interesting analogy. I like it. Yeah.
so
So
just
then I'll just get a calculator for that part.
yep, try that.
30 over 60. I got 1.5
Okay. Very good. Centimeters.
cubed.
Nope. This
No, I
just
meant.
this
Oh,
just
okay, my bad.
walking. How far
Yeah,
did
I
you
got too
walk?
excited there.
Yeah. Now
Um,
the next thing we can find is the area of this thing. Like we want to eat it. We want to know how much how big the slice is, I guess. So the area of the sector is the angle out of 360 pi r squared.
um, so then I'm not. Okay, so I'm taking the angle out of 360 pi r squared, so it's just gonna be 30 again, correct?
Yes.
And then the radius is 9, so pi
Okay.
9 squared,
Great.
and then 30 over, and then I'll put that in the calculator. So 30 over 360 times 81 gives us 6.75 pi.
Okay. And then
And then,
centimeters squared for your
yeah.
units. Good.
So okay, wait. So the one above is A to B, correct?
Yes, it's the length from A to B.
And it's 1.5 centimeters.
That's right.
And then the one below is the surface area of the entire pizza slice, which is whatever that was, 6.75 centimeters. So the first one is figuring out how far A and B is, and then the second one's figuring out how much of the surface area of the triangle there is.
Yeah,
And that's all?
that's it.
Okay, I don't know why I didn't get that like the first 5 times we did that.
That's okay. Don't be too hard on yourself. That's what we're doing, trying to get it clear. Um,
Yeah, okay, that's man, all right, yeah, that's so odd the way like you can just not get something until you do.
all right. It says to and you kind of alluded to this when we were doing problem three. It said use your 30, 60, 90 triangle to evaluate the following. What I don't know is whether they gave you. You don't have this printed, do you? That's these pages.
I'm not sure if I have that exact problem printed.
Okay, I will.
I
I'm
do
gonna.
not have that one.
Okay, so 30 degrees is
Oh, actually, never
across.
mind. I do. All
What
right.
what do they give you over here, if anything?
Um, they give me a right triangle 30, 60, 90.
Do they label any of these angles, sides?
They labeled the top most point is 60 degrees. They angled the one down there is 30, and then obviously the one with the square is 90.
Anything else?
Um,
So far,
there
they're not really
is,
helping you much. That's what I'm
yeah.
asking. How much I
There's
need to give you.
I mean, they told me the shortest leg is 4 feet long, so I wrote
Oh,
four
they did.
feet
Oh, that's
along the
good.
60.
That's good. And
And
then they give you anything else?
so then there, no, they have not.
Okay. All right. That's actually almost worse. So they're not giving you the reference triangle, which is what I thought they were going to give you here,
Uh huh.
which would be good to go in your notes. 30 degrees is across from the short leg. 60 degrees is across from the long leg. The
Oh,
short
okay, that's a
leg,
good way. That's a good way to keep that memorized.
yeah,
30 is short, 60 is long.
yeah.
And I guess that makes sense when you think about it as well.
Mhm. So now the short leg is usually referred to as X, and then the hypotenuse is 2X.
And then,
You were
so,
asking about the,
and then that's square root 3. So the 30, 60, 90 triangle, the hypotenuse is always twice as long as the shortest leg.
yes,
And then, okay, so then I guess that would be the longest, or the hypotenuse would be 8. And then uh, the longest, or 60-degree line would be 4 square root 3.
yes.
And then x, 2x, x square root 3. Um,
All right, so we can now find the cosine of 30 degrees.
yes. That would
So
be,
I'm gonna scribble these out because we're gonna need more. Cosine of 30 is what over what? Adjacent over
is it,
hypotenuse.
yeah,
What does
adjacent over
that become?
hypotenuse. So then that would be, does it, so when I'm doing this, am I looking at this from the 30-degree angle?
Yes, you presume that you're standing there at the 30 degrees and you figure out what's
Okay.
adjacent, what's opposite to you.
It would be 4 square root 3 over 4.
That's adjacent over opposite. We want hypotenuse on the bottom.
Oh my gosh, my bad. That's 8.
Okay, now this does reduce. The 4 and the 8 reduce, becomes the square root of 3 over 2.
Okay. And then would I just keep it like that?
Yes. Now let's
Okay.
do the sine of 30.
Um, so then sine 30 would be uh, is that sine's opposite over hypotenuse, correct?
Yes. Good.
Um, that would be 4/8, 1/2.
Okay, I like it. Now I want you to do cosine of 60 for me, which means you're gonna switch where you're pretend like you are. You're
Right.
now
All right.
up at the
Oh,
top.
okay. Yeah, that's easy. That's how you figure out where you're looking. All right. Yeah. So 60 cosine. That is the adjacent and hypotenuse, correct? So then that would be 4/8, which is 1/2.
Okay. And sine 60.
That would be opposite over hypotenuse. Four square root 3/8, which would then become square root 3/2,
Okay.
which is
Do you
the
notice anything about
same.
this?
Yeah, notice they're actually like switched in a way.
They are.
I never
Let's see
knew
what
that.
let's do tangent of 30 next. So go back to the 30.
Is that hypotenuse over adjacent?
It's opposite over adjacent. So that's
Opposite over
up
adjacent.
here in our lesson. Let me just show that to you one more time. That's in your notes. Like this needs to be really well memorized, understood before your test.
All right, I'll make sure to have that down.
Yeah, but you keep asking or whatever. The tangent is opposite over adjacent.
Opposite over adjacent, and then so then opposite would be x square root. Oh, this is for 30. Opposite would be 4/4 square root 3, which would then just
Okay.
be 1 over square root 3.
Okay. Now this rationalizes to, and you multiply the top and bottom by the square root of 3 over 3. So it ends up being square root of 3 over 3 is your final answer.
Um, yes.
Okay. Now we want to do the same thing for tangent of 60.
All right, so then that would be opposite over adjacent. So that'd be 4 square root 3/4, which would give us square root 3/1.
Yes,
And
that's it.
that, yeah, okay. And then
You,
if it's square root 3/1, would I just keep it as square root 3?
yeah, yes.
All right. That's not too. So
So
that's
there's,
so tan's the only one where they're not matching up with anything.
well, they're actually reciprocals. See how they're the flip. Let me see if I can show you that. These are flip.
Uh-huh. Oh, actually, yeah, that's true.
So there is a kind of a way to figure that out.
Flips. So the others match, that one flips.
Reciprocal is the more mathy word, but that
Uh-huh. Yeah, I'll pretend that I'll remember the reciprocal for that.
okay. All right, so next problem here is another special triangle.
Another special
And
triangle.
we actually ought to do the same thing for this one. Might be worth doing here. So I'm gonna I'm gonna give you that this is 20. Okay. So in a 45, 45, 90 triangle, whatever value each of the legs are when they're the same,
Hmm.
you multiply by the square root of 2 to get the hypotenuse.
So, okay, wait. So we know that the hypotenuse is square root 2, and
Times
then we know
whatever
there's
the
two
leg
legs.
is.
times whatever the leg is. And we know the two
Yeah,
legs are always the same for 45, 45, 90.
that's right. So what would the value of x be in this problem?
I believe it would be 20, 20, or well, 20 and 20, and then it would be
I'm
20
sorry, the
squared
hypo
root
yeah, 20 squared root. Good. Now let's do this. Let's find the cosine of 45 degrees.
2. So then the cosine is adjacent over hypotenuse. So then that would be uh 20 over 20 square root 2.
Okay.
And then that would just
It's,
be 1 over square root 2.
and you got to rationalize. So you
And then
multiply
that would
top and
be
bottom by root 2.
square root 2 over square root 2 would then become uh okay, wait, am I crazy or would it still just be square root 1 over square root 2?
It becomes a square root of 2 over 4,
Is
which
it so
becomes
if there's two square roots together, does it just make it like in this scenario, square root 2 times square root 2? Would that just make it become like 2 times 2?
square root of 4, which is 2. You
Oh, so
multiply the
you're
numbers.
reducing
Yeah.
it. Okay,
Yeah.
right. Yeah, that's kind of a no-brainer for that. So then if it's square root 3, square root 3, then it would just become positive 3.
Yes. Yes.
Okay. All right, that makes sense. All right. And then I
Okay.
guess
So,
do
so now
you want all
let's
the
do,
others?
yeah, do the sine of 45 and then the tangent of 45 for me.
Opposite over hypotenuse. So then that would be 20 over 20 square root 2. And then we know it's going to be the exact same thing. So it'd be square root 2 over 2.
Good.
And then for tangent, that's opposite over adjacent. So then 20 over 20, which equals 1.
It does equal 1. Yeah. Good. So the thing to maybe take down in your notes for your reference sheet is this reference triangle and then this other reference triangle. You want to make sure you've
Okay,
got those potentially down.
that sounds good. So, and those are the only two I'll probably be tested on, I'm assuming, correct?
Now, I wish I had your test in front of me. I'd probably give you every problem just like
Yeah.
it, or I mean, but I can't say for sure. You can always, read body language. You always go up to your instructor and just say something like, hey, I'm uh I'm thinking about studying this. Do you think it'll be on the test? And just wait and see what they have to say.
Yeah, that's always a smart way to do it.
All right. So the I would go with the page. All right. 5 we already have answered, but I'll just snip it in just in case here. What does SOHCAHTOA stand for? It's what we've been doing. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent.
Okay, all right, yeah, I guess that makes sense. Sine, cosine, tangent.
All right. Now we're up to some transformation problems.
And then that I
We uh
okay.
we we had a list of transformations at some point. You may consider putting those on your reference sheet.
All right.
But
I will
here
definitely
here they're
do that.
here they're giving you the transformation. They're telling you that A, B, X and Y go to X negative Y. So you just need to write the ordered pairs of, well, they don't you don't have the original. I would like to see the originals, but wow, this is written really weird. Okay, we're gonna do this. I'm gonna move this to the right. We're gonna make a little table here. We're gonna put the ordered pairs in for A, B, and C. Can you give me those ordered pairs, please?
Um, so so I know that A is -1 and 7,
Good.
And I know that B is 2 and 1, and C is
Okay,
-4 and 1.
perfect. Now you just have to use that rule there.
So
A to
then,
B becomes A to minus or A comma minus B.
so then I guess that'd just be -1 to -4,
For
-7,
which,
-1, -1.
oh, okay, you're doing them one at a time, or you're doing the,
Yeah.
all the, okay. All right, and then, when you flip that, it's like, well, what does it become? So, of course, they didn't give you enough room.
Yeah.
Oh my gosh, that would,
Just making your
so,
job harder.
well, you're the guys that need it. I don't,
Yeah.
I can adjust here. You know, student, you're like, wait, there's no room. What am I supposed to do? And, all right, so, all right.
Yeah, so
Next
then
one's,
that's what it would
why,
look
why,
like.
why don't you try letter B here on your own and let me know if you have any questions. This is the rotation rule.
So I'm taking the number and I'm subtracting it by 5 and by 3.
Yeah, no, that's interesting. Oh, then you do this rotation. Okay. Yes, you do that first. So you're going 5 left, 3 down.
Okay. A 7 B C. B is 2 and 1. C -4 and 1. And then Okay, so my final answer is 6 for A, 6 and -4,
Okay.
B 3 and 2, C 9 and 2.
Okay. Any questions on that? I mean, feel good about that?
Um, yeah, I feel solid on that. That's not too bad.
Okay. There were a number of those rotations. There was reflections over the y equals x. Just maybe take a look at our past notes or what you got in class. All right, let's take a look at number this new problem here. It's some sort of a quadratic thing you guys are doing. So describe each transformation on a separate graph, find the final graph uh, with all transformations. So it's okay. So we're supposed to be able to look at something like this. F of x equals -2 parentheses x plus 2 squared minus 2. Wow, why so many twos? And determine all the transformations.
Uh-huh.
That's critical. It's like do you know what's happening here? Like what is the x plus 2 in parentheses? What does that do?
Um, it's moving it to the left by 2 units.
Left 2, perfect. And then there's a -2 out in front of the x plus 2. So we break that into two parts. You either put you even treat the negative as coming second or the 2 coming second. It doesn't really matter. You just got to get them in the right order. I generally
Uh-huh.
show the the 2 by itself first and then deal with the negative. So it would be a vertical stretch of 2.
And then
Then you got
yeah,
that negative out in
uh,
front,
reflect over the x-axis
reflect over the
and
x,
move down 2 units.
and then down 2. So then what they're trying to get you to do next is say, okay, well, if these are the points, negative 1, 1, 0, 0, 1, 1, and we apply all the transformations, which we can do all at once here, the only one that affects x is the left 2. So I know it's plus 2 here. It's still left 2. You're subtracting each of these by 2.
So then -3, -2, -1.
Good. And then you've got to be able to do, now this is where it's hard. Vertical stretch of 2. You're multiplying the y values by 2.
2. So then that would be 2, 0, 2.
But if you can, if you need to, you can make kind of do intermediate ones, but then you negate each of them.
By 2. So then it would be 0 -2, 0.
No, you negate. That's number 3 is to negate when it
Oh,
reflects
my
on the,
bad, my bad. Yeah, -2, 0, -2.
and then down 2 is where you subtract 2.
-4, -2, -4.
There you have it.
And then,
That's it.
yeah, that's it.
That's it.
Yeah, that one's not too hard. I remember that stuff pretty well, thankfully.
Yeah, so we're really close to being out of time. Actually, I think we did get through everything but the last question there on that second email you sent. So maybe if you schedule another lesson, we can look at some of those other things you sent last time. I guess it was the same thing. So we are unfortunately out of time for tonight, Zach. Gonna have to stop right here.